Hello guys, I welcome you all to my YouTube channel. This is Adarsh Kasture and I'm from International Institute of Professional Studies under the guidance of Vivek Srivastav sir. Today I'm going to provide you whole tutorial about Docker in this through this PPT, and I'm going to explain you all the concept which is going to help you to understand what Docker is and how to use it. So let's starting with the topics we are going to cover today. Let me tell you that I'm going to explain what is Docker, the dependency hell problem, the Docker solution, VMwares, and virtual machines, and what the containers difference between them, and the Docker on desktop is the tool which is going to be helping us do this practical um, lab, like a lab. You do something on your lab for understanding the concept more thoroughly and more industry level based. So starting with the topic, what is Docker? Let me tell you that Docker is an open platform for developing, shipping and running applications. This means what? Running applications means there must be something that which is being developed. Okay, an application is being developed, and now we are going to be deploying it on some server, or let's say your laptop. Okay, you developed some website and you deployed on your laptop. So this is how you have did the whole procedure of software development life cycle. And while this whole software development life cycle, there is a need of a Docker in between. Why? I'm going to tell you why. So let's first understand what this technology is. Okay, it leverages a technology called containerization to package software into standardized units. The container, understanding the container is very important. Okay, if you it is the mostly asked questions among the college universities level examinations, that what is the difference between containers and the virtual machines basically. So you must know what containers are. Without these containers you are not going to understand the far ahead topics like Kubernetes or Jenkins or CI/CD pipelines. Okay, so containers, a lightweight standalone executable package that includes everything needed to run a piece of software: code, runtime system, tools, libraries, and settings. Okay, so a container is something that contains everything from the code itself to all the dependencies to all the configurations you are going to do, you have done in your laptop, and all the environment variables, each and everything. Okay, so uh, this container is something as a whole package. Okay, so I'm going to tell you how this container is going to be used uh, for uh, for like efficiently deploying or efficiently sharing whatever the things you have done. Okay, so this approach embodies the promise of write once, run anywhere. Okay, ensuring your application behaves identically across all environments from your local machine to production servers. Okay, so ensuring your application behaves identically across all environments. The container essentially abstract away the underlying infrastructure, providing a consistent environment for applications. I will going to explain you. Okay, so first understand the dependency hell problem. Without Docker, a recipe for inconsistency. Before Docker, deploying applications often led to significant challenges due to environmental inconsistencies. A developer would build an application locally, then hand it over to uh, quality assurance team or production teams, only for unexpected issues to arise. Okay, so you must have heard it somewhere that it is an infamous like code or something. It works on my machine. Like if someone is saying yes, it's work on my machine, that it means that you have shared it 100% correctly. Like I'm going to explain you with a pen and something. Okay, let's say black. Okay, See, here you are a developer, let's say, and here is a quality assurance team. Okay, quality assurance team, and here is the operations team. Okay, let's say you have developed something. You have developed a software. You have given it to quality assurance team for testing. So this software has been handed over to quality assurance through something you have provided the code or something. So you have and you are having currently the hardware on your laptop. You developed it in your laptop. Okay, locally on premises. So you run all the commands, you downloaded all the frameworks or something to basically do the work. Okay, let's say you have developed a Tech website. So you must have downloaded the Node.js or the all the packages or modules you must have required for developing the software. So after the software has been developed by yourself and you have done whatever you could be and it is working absolutely fine on your laptop, you have given this software to the quality assurance team. Now the guy which is having the which is going to test your software does not have all these dependencies on his laptop, and these dependencies are really complex. Okay, so complex in the way, not that complex, but complex in a way that you must be using some version of like say Node which is higher than he is having right now. So these type of things changes all the environment variables and configurations which is in the quality assurance guy is having. So this lead to a problem which is the hell problem. Okay, dependencies doesn't match after so many communication, and communication gaps are wide. So these arises the problems that quality assurance guy says it doesn't work on my machine. Okay, so the developer says it works on my machine. This gives a rise to the problem that it is not working on my machine. Then what should I do? I'm having an operating system of Windows, Ubuntu, or anything. So the quality assurance guy should have the same configuration, same dependencies on himself. This problem was solved using the virtual machines. Okay, so that you as a developer provide uh, installed whole the dependencies or all the things you required for the software on a virtual machine. You provided that virtual machine to the quality assurance guy, and now he's easily going to test all the software flaws you are having on your software. Okay, so this is how the communication between them was made easier using virtual machines. But this also arised some issues I'm going to tell you later. But this is how it was done after. So, and once quality assurance team has done all the things, it is going to hand over the software to the operations team, and finally it is going to be deployed. So you are going to use it as a user. This is how it is being done. Okay, so uh, I'm what told you that all the dependencies right now on your local premises gave rise to the things like different OS, having library version differences, missing packages, and these are really complex to communicate with someone. Okay, configuration drift, so environment variables, and many more. Okay, so let's say wait a minute. Now I'm going to explain you that how dependency held traditional workflow worked. Okay, so this is the same thing I was explaining you previously, that quality assurance was having something like these, and the developer gave these, and it worked, and the production team did have these. So these gave the rise between the gap. Okay, so moving ahead, I would like to tell about the consistency workflow Okay, how Docker is going to be solving it, okay, and on what level, okay, and how easily. That's what matters. If you are not having a software, a solution which is not easy to use, it is not going to be used anywhere, okay, even though it is how much having efficiency or something, but it is not going to be used unless and until it is not easy. How Docker solves it? The consistent workflow. Docker transforms the development and deployment process by packaging applications and their dependencies into immutable images, guaranteeing consistent execution across all environments. This means what? This means that Docker is going to do a packaging of the whole your application along with the dependencies and along with the whole environment you are having currently in your local machine. Okay, so these are being packaged into a um, something, and uh, we call it container. Right now it is not here mentioned here, so it is saying all about the images. I'm going to tell you about images. Images nothing but it is like an instance of a container, okay, which is you are going to be basically share, okay, immutable images. That's what written here. Okay, before Docker, the virtual machine era. So this is where the difference between them lies. That's what I was saying about. Okay, this is how the we were having a solution of the dependency hell problem. Okay, through virtual machines. But why was there a need to introduce something like Docker? So this is the topic where it lies that what drawbacks and what the problems virtual machines gave rise, which helped us to shift in Docker. So VM architecture is something that explains us everything. Okay, if you understand, you must know what this is. And this is basically the architecture of how virtualization works and hard. Basically, let's give an example. There is an hardware you are having right now of 128 GB and having a host operating system of say Unix or Linux, or having a hypervisor like bare metal, or no, bare metal cannot be here because it's an OS. So you're having a hypervisor which is converting your hardware, local hardware to virtual machines, and these virtual machines, let me get here. These virtual machines right here, this is the one virtual machine in which application A is running right now, and it is having a guest operating system. So I'm going to tell you that how these are having a difference. Basically, the drawback lies here that these operating system is using the hardware of this, and it is requiring its space and all the basically the hardware. Okay, utilizing the hardware is something else, and uh, eh, utilizing this part is only utilizing it for and this is the only part we are going to share, okay, to other person who is going to use. But what about this guest operating system is something which is not uh, going to be helpful to us, okay. This is not what we wanted for us, okay. um, this problem was solved in a Docker. Like there was, see, you as you can also see, there is no guest operating system here. Docker engine is converting the making the containers. See, like it's here VM1, virtual machine 1, and this is what container number 1. Okay, this is how the difference lies here. This is a virtual machine, this is a container. Here hypervisor has made the virtual machine. Here Docker engine is responsible for creating the containers. So basically the hardware which is not being utilized in the VM architecture is being utilized in Docker architecture. How? This is because of Docker's specific properties like not using the uh, not creating the operating system for each containers, and only using the kernel, same kernel. Okay, same kernel. All containers uses same kernel. This makes it efficient. For what? This makes it efficient and for utilizing the hardware and making it much faster than VM. Okay, this is how the main drawback of virtual machines gave rise to the introduction of Dockers. Okay, so this is like the hyperware is equivalent. This hyperware is equivalent to Docker engine. Okay, and this host operating system is also present here, but not this layer is present here. Okay, you can see there is no layer present here of this. Okay, guest operating system. This is where the main difference lie. Okay, so it is not being present, and the application we want to run can be run on the containers without any like flaws or something, and with all the dependencies. As I told you, container contains all the dependencies as well as the software or application you have developed. Okay, challenges with virtual machines can be heavy. Sorry. Virtual machines typically consume several gigabytes. Slow startups booting a virtual machine could take minutes. Okay, so this can also be the point that starting up a virtual machine is leading, and this is also like wasting our resource. Now we are having a hardware of 128 GB, and out of it 4 GB or 20 GB is being used by the operating system itself, the guest operating itself. Why is there even a need for it? If this container or this Docker engine is directly communicating to the kernel of the OS and it is utilizing the hardware directly, okay, so why is there even a need? So this is where the drawback has been solved in Docker. I actually made this diagram right before I was going to explain the virtual machine architecture only without this diagram. But after making this diagram, it is also clear that how much difference and drawback has been um, solved here. Okay, resource intensive, required significant CPU memory and storage. OS duplication. Every virtual machine carried its own full operating system. This is where the line lies. Okay, this is where the main thing lies. Operating duplication. Every virtual machine carried its own full operating system. Okay, so let me explain. Moving ahead for the next topic. Okay. Hmm. So, virtual machines versus containers. Here is a key difference between them. Like the operating system and shares the host kernel. That's what I was saying, that it shares the host kernel. Okay, so this makes it much faster and does not means to utilize the. This means that utilizing the hardware mean more and not wasting it on the guest operating system. Size is in GBs and MBs. Here it is MBs because although it is having dependencies and all environment variables in itself, but it goes up to only MBs or sometimes GBs because Docker has made it its properties like these, so it is efficient to share between your teams. Startups is between minutes or it takes seconds only. Isolation is strong, and process level is going to be overhead highs near zero. So this is the difference between. But let's see what has been written here. Apartment building, each tenant has a full kitchen, bathroom, and furniture, heavy, costly, and resource intensive. Okay, so this is something like a resource, and each each the flat owner is having its own kitchen, bathroom, and everything. So uh, this makes it inefficient, and this is how a container is. It is being share same engine but offers a different menu application. It is a lightweight thing to use. Moreover, going ahead to uh, okay, Docker on desktop. See, this is very important topic. So to begin your Docker journey, you will need to need the right tools and a basic understanding of common commands. So uh, Docker desktop is something which is an essential tool for you guys to basically you're going to use it anyway if you're working in an MNC or or somewhere. So because this makes so much things easier than doing it the other way. If you're working in an Amazon unless so essential tools is a Docker desktop, and there is a thing called Docker Hub. So Docker Desktop is the tool I told you. Okay, this all in one package includes a Docker engine, CLI, Docker Compose. So basically, this is the um, user interface provided similarly as the Windows. You know that Linux is the same operating system which works as the Windows, but Windows provides us an additional layer of user interface. This is how Docker Desktop also provides us. Essentially, in previous time, Docker made this whole Docker and uh, Docker engine and other things for just only for Linux users or Unix users. But moving by seeing that many users are being using it and getting fond of it, it moved to make the Docker desktop. I'm also going to provide you where you can read all thing about the Docker desktop, and I'm going to tell you that what Docker Hub is. Okay, Docker Hub. It's something like GitHub only. Okay, you put your resources or something that you have made, software and any other files or documents, everything on a repository on a GitHub. So it is a cloud-based software which is being provided to the developers for putting their resources in a basically a single place, and other your teammates or your partners, your collaborators can pull these resources to use in their own local machines. Okay, this is how GitHub basically works. Similarly, Docker Hub is something like a cloud station where everything, literally everything, lakhs, thousands, crores of uh, uh, dependencies, packages, um, all the frameworks, languages, all the compilers, everything has been kept, and you just need some commands to run, and everything is going to come in your own container. So you doesn't need to have it in your own PC, and there is no need to configure it. Okay, that is the best part. You don't need to connect the lines between what things you are doing. You just need to be focusing on your code and code's logic, nothing else. Okay, this is how Docker is helping us out at that extent. Okay, so this is Docker's public registry where you can find and share container images. Okay, that's what is container images is also being put it. put it in the Docker Hub only. I'm going to tell. I think I have not told you that what Docker image is, but uh, ahead in the video I'm going to tell you. Uh, your first Docker interaction. Install Docker desktop, open your terminal and verify the installation, and something written here, Docker commands. So listing the images like you created. Let me first tell you all the commands. Run a container is the command, this, and listing running containers, stop containers. You're going to have a whole interface to do all these things, and you can also read the Docker document for knowing the basically the things. But I'm going to here tell you about what Docker image is. Okay, so Docker image is literally a thing that Docker image. Okay, and here is what you have made. It is Docker container. Okay, and here it is your what you have made a. Let's connect the lines first. See, you have made a Docker container. Okay, using what? Using Docker desktop application, you can make a Docker container. There is a command to make your Docker container. Okay, you're going to put all the dependencies and everything here, and now you are going to create a Docker image. Okay, you just do Docker run and it creates the image. Okay, it is going to have a unique ID, and using this ID you can share this image, and this container has been uploaded to the cloud. Okay, this container has been uploaded to the cloud. Now each and every collaborator you are having, or the team you want to share your code or software with, can now pull this. Okay, pull this image, and pull this image and test or deploy it. Okay, it's it's all you need to know, that containers is making some while running make it an image, and this Docker image has been put it into what? Docker Hub. Now Docker Hub is going to be the one station from where your colleagues can pull this image and do whatever the thing they want to do. Okay, this is how the whole thing works. I i i think you must have understood all the things. Now I'm going to show you where you can basically do the uh, desktop dockers, read the dockers document and everything. Okay, as you can guys see here, let me just erase this thing. Okay, I'll explain this. I think you must be watching it. Docker Desktop is, yeah, you can visit this website like right here. It's docker.com, in which it's an official page, and you can also see the Docker engines present here. And Docker daemon is the main thing, main core component. Like the operating system has the kernel, Docker daemon does all the things that you want to do between. And Docker Desktop is something you can install it from here. Install Docker Desktop for your Mac, Windows, or Linux, or whichever thing you are using right now in your laptop. And this is a compatible thing, and you can also read the documents and all the commands you can run. So you are going to be having a knowledge about how Docker is basically running. So thank you for watching my video. If you are right now watching up to right now, I would like to also tell you that Kubernetes is something. I don't think I'm having much of time, so I'm going to explain it here in two lines. Kubernetes is something which through which you can run hundreds of containers at one time. Okay, and CI/CD pipelines is something that enhances the deployment in the between phase. So Let's see if I'm going to make that video in future. Okay, thank you guys.